All right. So the SafeProwl robot has two sensors and one set of quad motors used to fly, since it is a quadricopter. And I'll run through the design really quick. Right here, our blue LED signifies our infrared sensor slash antenna, in which we receive coordinates from the Roar Vision platform that we institute as well. And we also receive routing information as well as how the if the safety is in need or if it's already been dealt with. The red LED is just an illumination light for the warning light. We have our four motors that are used for the four propellers, as well as two obstacle sensors we're using distance sensors to then simulate if we're flying towards an obstacle. And so I'll run through the code as well. To start with, we establish our variables right here, as well as our pin setup. This is a placeholder variable, which we set to 1. The Roar Vision is just signifying that there is a safety risk that needs to be addressed, which we then use in the Safe Verify program, which will notify staff of security alert, and it will continue notifying staff of security alert as long as that Roar Vision is sending that true Boolean value. We have our route program, which determines a route based off of the position X and position Y, as well as a reroute based off of the avoidance of the obstacles, which is run on every loop. And then we have our home system, which then once the Boolean reverses to a false for the Roar Vision or a 0 value, saying that there's no longer security alert, it routes home and returns to home base. So then our loop, we use placeholder X and Y values when we run the route command, in which it initiates flight. As soon as it starts to initiate flight, we run our motion sensor distance calculators, and then we start lighting up the sign for the warning sign. And then here are our two avoidance protocols. So whenever it is not avoiding something, it will always say flying forward just as a status. And then whenever it is avoiding something, it'll say avoiding left or avoiding right obstacles. And then at the end of our loop, we always run the route and reroute command, since our avoidance will change our flight path. And then at the very end of the program, we have our Safe Verify, which is double checking that Roar Vision is still equal to 1. And if it's not, it returns home. And so that is the program. I'll go ahead and show you the simulation. So on the monitor, you'll see it'll immediately start receiving coordinates and heading to intercept. At the moment, it should be flying forward the whole time, of course. You'll see that when it started, it was under 20 inches, so it's avoiding left obstacles. And you'll see on the motors that the two left motors speed up, because as a quadricopter flies, if it wants to tilt, it has to speed up or slow down certain sides. And you'll see whenever there's not obstacles and it's flying forward, they all sit at the same RPM. And the same goes for the other sensor here. If we bring it under 20 inches, it speeds up. And the serial monitor adjusts accordingly. And then once you receive the input from the Roar Vision that safety is assured, it goes ahead and runs the Safe Verify, in which case it returns home and prints returning home base. Thank you.